Hey guys, welcome to part 2 of the AQA 2017 Further Maths Paper 1 walkthrough. So in part 1 we go up to question 6, in part 2 we're starting at question 7 and we're going to do the next 6 questions. So, is anyone out there doing further maths? I don't know, let me know down below in the comments, tell me how you found it. Are you going on to do A-level maths? Because that's my next trip with Maths Revolve, is to start busting out the A-level videos. Okay, so, question 7 then. The function f is given by f of x is root 2x minus 5. We want to circle the range of values that gives the domain of f of x. So the domain is the range of x values that produce our function with no problem. So it's the range of values x is allowed to be. So let's think about this function here. We've got the square root of 2x minus 5. So square rooting is going to give us a problem if we have a negative number underneath the square root sign. So 2x minus 5 is absolutely fine to be 0 or above. So let's set 2x minus 5 greater than or equal to 0 at 5. 2x is greater than or equal to 5, and then divide by 2, x is greater than or equal to then 5 over 2. So that guy is our guy. Part B wants us to work out x when f of x is 1.2. So we substitute in f of x is 1.2. 1.2 equals root 2x minus 5. So we're then going to want to square both sides. So we're going to get 1.2 squared is 2x minus 5. So we need to work out 1.2 squared. Let's break that down. So 1 times 1.2 is 1.2. 2 times 1.2 is 2.4. So 0.2 times 1.2 is 0.24. So 1.2 squared in total is 1.2 add 0.24, which is 1.44. So 1.44 equals 2x minus 5. Add the 5, 6.44 is equal to 2x. And then finally divide by 2, we get x is 3.22. And then part C asks us to work out the value of f of 2 and 5/8, giving our answer as a fraction in its simplest form. So first thing I'm going to do here is write 2 and 5/8 as an improper fraction. So 2 and 5/8 is 8 times 2 plus 5 all over 8. 8 times 2 is 16, plus 5 is 21. So we've got 21/8. Okay, so then we're going to get the square root of 2 times 21 over 8 minus 5. That 2 times 21 over 8 is 21 over 4. And now I'm going to think of 5 in terms of quarters. Every one whole is 4 quarters. 5 wholes is then 20 quarters. So we got 21 quarters minus 20 quarters, which leaves us with the square root of 1 quarter, which gives us 1/2. Jobs are good for question 7. Okay, question 8, we've got a nice little quadratic sequence, so we want to find the nth term of this guy. So first of all, find our differences. Tan to 33 is 23. 33 to 64 is 31. 64 to 103 is 39. Then find the differences of our differences. 23 to 31 is 8. 31 to 39 is 8. Awesome. So if we half 8, that gives us the quadratic part of our sequence, which is 4n squared. So if we now write out the first 4 terms of 4n squared, it's 4 times our square numbers. So 4 times 1 is 4. 4 times 4 is 16. 4 times 9 is 36. And then 4 times 16 is 64. So we then take the quadratic part out of the quadratic sequence. So we minus the corresponding term from 4n squared away from the original term of the original sequence. So tan take away 4 leaves us with 6. 33 minus 16 leaves us with 17. And then 64 minus 36 leaves us with 28. And then 103 minus 64 leaves us with 39. So now we've got the linear part of our sequence. We now need to find the nth term of this guy. So find the differences. Hopefully they're all the same. 6 to 17 is 11. 17 to 28 is 11. 28 to 39 is 11. So we're something to do with 11. And now if we set n equal to 1, we then compare it to the first term of our linear sequence. So if n is 1, 11n is 11. How then do we get down to 6? We subtract 5. Let's just check that works for the second term of our linear sequence. So 11 times 2 is 22, minus 5 is 17. Jobs are good. And then, so our whole linear sequence is 4n squared plus 11n minus 5. If you want any more practice on that, I've got 2 videos on quadratic sequences, so be sure to check those out. Jobs are given for question 8. Okay, question 9, we've got this rectangle with the lengths 2x minus 3 and x plus 1. We want to show that the area of this rectangle is 2x squared minus x minus 3. So it's a quadratic expansion. We want to do 2x minus 3 times x plus 1. Use whatever method you like to do that. 2x times x is 2x squared, minus 3 times x is minus 3x, and then 1 times 2x gives us plus 2x, and then 1 times minus 3 gives us minus 3. If we sharpen that up, we get 2x squared minus 3x plus 2x is minus x, and then we got the minus 3 at the end as we wanted it. We've shown what we want to show by a cheeky little QED. Okay, and then for part B, we're told the area of the rectangle is greater than 7 centimeters squared. So, we want to find the range of values for x. So, first of all, we just worked out an expression for the area. 2x squared minus x minus 3. Now we know that that has to be greater than 7. So if we take the 7 away, we get 2x squared minus x minus 10 has to be greater than 0. So let's now see if we can factorise this bad boy. So one of our brackets is going to need a 2x, the other is going to need an x. Now our two numbers have to multiply to 10, or minus 10, and we have to end up with a sum of minus x. So, for example, here we could do x plus x plus 2, like that. Now that plus 2 is going to multiply with 2x, which is going to give us 4x. So if we then whack a minus 5 in there, we can get minus 5 times x. So minus 5 times x is minus 5x plus 4x gives us that minus 1x as we need it to. Now, let's for a minute imagine that we were actually solving this equation equal to 0. Then we would get either 2x minus 5 is equal to 0, add the 5, 2x is equal to 5, so x would be equal to 5 over 2, or x plus 2 would tell us x would equal minus 2. Now only one of these solutions makes sense in context of the question. If x was equal to minus 2, 2x minus 3 would give us minus 4 minus 3, which would be minus 7, which is a negative length, which is absurd. That doesn't make any sense at all. So we're going to ignore this solution because it doesn't make sense in terms of our question. So we've got then x is equal to 5 over 2. Now we want the area to be greater than 7. So we want x then to be greater than 5 over 2, or 2.5. That's our answer. Jobs again. Okay, question 10, a nice little bit of geometry, although it's probably quite tricky. So circle C1 has centre L and equation x minus 3 squared plus y squared is equal to 36. So from that we can write down the centre is 3, 0, and the radius is 6. By the equations of a circle, if you're rusty on those, I do have a video. Go to the equation of a circle, check that out. Okay, and then circle C2 has centre M and equation x minus h squared plus y squared equals 64. So from that, we know the centre is h, 0, and the radius is 8. So those bits of info may or may not be useful, but it's good practice. We're then told LM is perpendicular to NM. So we got that down on the diagram, and the circles intersect at the point N. So let's now go down to our diagram, see what we can put in. Well, we can put in the centres of our circle, why not? It'll be fun. So the coordinates of L are 3, 0. The coordinates of M are H, 0. Now we actually also know the radius of each circle. That's handy because these two radii meet at this point N. So the radius of the small circle is 6. The radius of the big circle is 8. Now we're inside of a right-angled triangle in which we know two side lengths. So we can now play Pythagoras. If we call 6a and 8b and our hypotenuse c, Pythagoras tells us a squared plus b squared is c squared. 6 squared is 36. 8 squared is 64. 36 and 64 is 100, which is c squared. Square root of that, we get c is 10. So the centre of circle C2 is 10 to the right of the centre of C1. So 3 add 10 gives us h is 3 plus 10, which is 13. Jobs again, nice question. Okay, question 11, we want to simplify fully x over x minus 3 plus 6 over x minus 3 times x minus 5. So to do this, we first of all need common denominators. So we need to turn x minus 3 into x minus 3 times x minus 5. To do that, we multiply the top and bottom by x minus 5. So we get x times x minus 5 over x minus 3 times x minus 5 plus 6 over x minus 3 times x minus 5. Okay, so we can now write this as a single fraction. We've now got, I'm going to expand the brackets as well. So we've now got x squared, the brackets up on the top, not on the bottom. If we are able to simplify this, there's going to be a common factor between the top and the bottom. So I'm going to expand the brackets on the top. X times x is x squared. X times minus 5 is minus 5x plus 6. And that is all over x minus 3 times x minus 5. We can now factorise the top. Hello, let's get rid of that. Failed attempt. Okay, so we can factorise the top. So we will get x minus 2 times x minus 3 up on top over x minus 3 times x minus 5. We're then happy as Larry. We've got a common factor of x minus 3, which we can cross out. So then our final answer is x minus 2 over x minus 5. Jobs again. Okay, question 12. So this is the last question for part 2. If you found this useful, don't forget to give us a thumbs up and get subscribed. It's fun. So, let's see here. So the transformation matrix M represents a 90 degrees clockwise rotation. we want to write down this matrix M. Now, write down suggests it's obvious. Personally, I could never bloody remember these transformation matrices, so I'm going to take you through how to do it. So, we're going to pick 2 points on the coordinate axes. We're going to have this point here, 1, so good start, 0, 1, and this point down here on the x-axis, which would be 1, 0. So if we rotate these guys by 90 degrees, this guy is going to come down here to 0, minus 1, and this guy is going to come down here to 1, 0. So the image of our transformation is going to look like this. So it's going to be 1, 0, 0, minus 1, like that. Now we know this is a multiplication of our transformation matrix, which for now I'm going to call A, B, C, D, times our original coordinate points, or our object. So our original points were 0, 1, 1, 0, like that. So if we then do a cheeky bit of matrix multiplication. Okay, so there's our setup. Let's do the 4 multiplications to work out A, B, C and D. So first of all, if we do 0, A plus 1B, we know that has to equal 1 up there. So 0A plus B equals 1 tells us B is equal to 1. So we can fill a line. Next, let's change colour. We then do 1, 0 times A and B. So we're then going to get 1 A add 0 B equals 0. Therefore, A is 0. Then, if we do the multiplications on the bottom row of the matrix, change colour. Okay, next we want to do 0C plus 1D. Now we know that that has to equal 0. So that tells us D is equal to 0. And then one last time, we now want to do 1, 0 times C and D. So that's going to tell us 1C plus 0D. Now we want that to equal minus 1. So that tells us then C is minus 1. So our transformation matrix is gonna be 0, 1, minus 1, 0. If you can remember those off the top of your head, awesome. Or if you use the trigonometric form, awesome as well. If you can't remember them though, that's how we work them out. Okay, then part B is asking us to describe fully the single transformation described by m squared. So this is just 2 repeated transformations of 90 degrees clockwise. So that's going to sum up to a rotation of 180 degrees, and that's going to be about the origin Okay, then part C is asking us to write down that transformation matrix m squared. So I'm going to go through how to do it. So m squared is 0 minus 1 times, 0 minus 1, 1, 0 times 0 minus 1, 1, 0. So our top left number is going to be 0 times 0, which is 0, add 1 times minus 1, which is going to give us minus 1. Our top right number is going to be 1 times 0, add 0 times 1, so that's going to be 0. Our bottom left number is going to be 0 times minus 1, add 0 times minus 1, so that's just going to be 0. And then our bottom right number is going to be 1 times minus 1, add 0 times 0. So that's just going to be minus 1 there. So that's our matrix. Let's fill it in. Why not? Okay guys, so that's it for part 2. I'm going to finish the paper off in part 3. Hope you found it useful. Leave me a comment down below. Let me know how you found further maths, etc. Take care guys.